Welcome back. Today we're going to talk about dividing polynomials in a couple of different ways. I'm just getting out my colors here. And the first example that we're going to start with is the division of these two polynomials. So 3x cubed plus 5x squared plus 8x plus 7, and we're going to divide that by 3x plus 2. I think part of this will be a review. Part of it may be new. We're going to shake off some of the rust. So anytime we're doing long division, so this is polynomial long division, what is being divided is going to go on the inside. So I'm going to put 3x cubed plus 5x squared plus 8x plus 7 goes on the inside. And then on the outside, I'm going to put 3x plus 2. If it's been a while since you've done either long division or polynomial long division, you know that we're comparing what's out here to each term and seeing what it's going to divide into. Well, when we look at 3x and we look at 3x cubed, I'm asking myself the question, what do I have to multiply 3x by to get 3x cubed? And so I'm going to put an x squared here because x squared times 3x is 3x cubed. Okay, and because I'm going to multiply what I put up here times both of these things, so I'm going to have x squared times 3x, which is 3x cubed, and then x squared times 2, which gives me plus 2x squared. Drawing my line. This long division algorithm is something we learned a long time ago, so we're shaking off that rust. And I'm going to subtract. So here I get 0, which is good. That's what I want. 5x squared minus 2x squared would be 3x squared. I will bring down my 8x. I will bring down my positive 7. And I'm asking that question again. What do I have to multiply 3x by to get 3x squared? So I need to multiply by an x, and you'll see these columns line up, so a positive x. Now I'm going to multiply this x by each subsequent term. So x times 3x would be 3x squared. X times 2 would be 2x. And I am going to subtract again. Get 0. Again, that's good. 8x minus 2x would be 6x. And I'll bring down my 7. Now I'm comparing 3x to 6x. So I need to multiply 3x by positive 2. So 6x, 2 times 2 would be 4. And when I subtract, I've got 6x minus 6x would be 0. And then 7 minus 4 would be positive 3. So now, there's nothing I can multiply 3x by to get 3. So the number parts match, but I can't multiply anything. So this down here is my remainder. That's my remainder. So it's asking me to write a summary statement in polynomial and fraction form. I'm going to show you what that looks like. So here's polynomial form. So as we look at polynomial form, what we're trying to write is, what is our original polynomial as a product of what we divided by and our answer. Let me show you. So our polynomial form is going to look like this. 3x cubed plus 5x squared plus 8x plus 7. We divided it by 3x plus 2. And so it's equal to our answer, so x squared plus x plus 2 times what we divided by, 3x plus 2, and plus our remainder. Okay, and so that is the way that we write it in the polynomial form. It's a product of what we divided by and our answer plus our remainder. Our second form is fraction form. And that's going to be written more like what the problem looks like. I'll show you what it looks like. So 3x cubed plus 5x squared plus 8x plus 7 over, and this is where the fraction part comes in, 3x plus 2, is equal to x squared plus x plus 2 plus our remainder over 3x plus 2. Okay, so think about this for a second. How are these two forms related? If I took this side over here, okay, and I multiplied it by 3x plus 2 to try to make it look like this other side, what would happen? Well, I'd distribute my 3x plus 2 to this, which would make this 3, and then this would be x squared plus x plus 2 times 3x plus 2. So these are two forms, a way to say, all right, what's my answer? My answer is x squared plus x plus 2 times 3x plus 2, which was the factor that I divided by, plus my remainder. So this is my remainder. And in the fraction form, my remainder goes over my original divisor. Okay? So that is the first example. The second example, what I'd like for you to do is pause the video right here, try it on your own, write it in both forms, and then you can turn the video back on, check to see if your answer is right. If you get it wrong, you can rewind the video and look at the explanation. So go ahead and pause right here to check out the answer to be able to try this one on your own, and then pick it back up after you've done it to see if you got it right. Okay, so hopefully you paused there. As we look at this one, I'm going to write it out. So I'm 2x to the fourth minus x cubed minus 2 divided by 2x squared plus x plus 1. So I'm going to put 2x to the fourth minus x cubed minus 2 on the inside. I'm dividing that by 2x squared plus x plus 1. I'm asking myself the question, what do I have to multiply 2x squared by to get 2x to the fourth? Now, undoubtedly what happens here is you start to realize, oh, I need to multiply that by x squared. Well, I don't have a column for x squared. And so what I need to do is I need to take, not that part, I need to take, and I need to make a place. And the place that I'm going to make is going to be a placeholder for my other values. So for future reference, if we have a case underneath here where we don't have all of the digits, here's what I'm going to do. Plus 0x squared plus 0x minus 2. Okay? And so I need to open this up and have all of my place values, or all of my powers of x, as it were, represented so that I have a place to put the answer. Because when I look at 2x squared and I look at 2x to the fourth, I've got to multiply this by x squared. So in order to accommodate that, I've got to be able to have, a spot for it. So x squared times 2x squared would be 2x to the fourth. X squared times x would be x cubed. X squared times 1 would be x squared. I subtract. I get 0. X cubed minus x cubed will be minus 2x cubed. And 0x squared minus x squared will be minus x squared. And I'll bring down 0x because I might need that placeholder. And I'll bring down my minus 2. All right, here we go. Keeping everything straight. Compare my minus 2x cubed to this. I know I need to multiply by a minus x. So minus x times 2x cubed would be minus 2x cubed. Minus x times x would be minus x squared. Minus x times 1 would be minus x. And then I need to subtract here. So this is 0. This is 0. This is x. And this is coming down as a minus 2. Okay, so now, when I look at my 2x squared and I compare it to my x, I'm asking myself, what do I multiply 2x squared by to get x? Well, the answer is nothing. So this is now my remainder, because my power down here is less than my power over there. So this is my remainder. What do I do with that? Well, I'm going to write it in polynomial form. So polynomial form. My polynomial form looks like this. I take my original, so 2x to the fourth minus x cubed minus 2 equals. And what I'm going to write here is my product of what I'm dividing by and my answer plus my remainder. So here we go. 2x squared plus x plus 1 times x squared minus x plus x minus 2. That's my polynomial form. So see, I've got my polynomial here. This is a factored polynomial plus another polynomial. No fraction. My fraction form is going to look a little bit different. It's going to be a rewrite of my original problem, 2x to the fourth minus x cubed minus 2 over 2x squared plus x plus 1 is equal to my answer, x squared minus x, plus my remainder, x minus 2 over 2x squared plus x plus 1. Okay, so here are my two forms. Notice, they have similar qualities, but the polynomial form is what I divided by times my answer and my answer, and this is my remainder. Over here, this is my answer, and this is my remainder over divided by. Okay, so all three elements are there. What I divided by, my answer, and my remainder, just the format is different. So for my polynomial form, it's what I divided by times my answer plus my remainder. In fraction form, it's my answer plus my remainder over what I originally divided by. Okay, that's polynomial division. Let's move down here to synthetic division. Synthetic division is a shorthand for polynomial division. Okay, so it's important to remember that all of the elements you need to be able to use synthetic division are contained in the problems for polynomial division. This is what it looks like in general. My k is going to go on the outside, and my coefficients are going to go on the inside. You're probably thinking, what is k? Where the heck does that come from? And it's important to remember that this k is a 0 of f of x. Okay? So basically what I'm dividing by is something that I know is a 0 of f of x. But it's going to be written as a linear factor, okay? And we're going to talk about that in the next part. But as you can see here, I'm dividing by x minus 3, and coincidentally, I'm dividing by x minus 3 here to give you an idea of what's going on. So, polynomial division, synthetic division go hand in hand. Well, what I'm dividing by here, this is one part, this is the next part. This is in the form x minus k. Okay, and so how do I do synthetic division? I'm going to take my coefficients, they come from here, so 2 minus 3 minus 5 minus 12. And on the outside goes my k, what I'm subtracting, so 3. And this is how synthetic division works. I am going to draw a line here. And down, I'm going to bring my 2. So the first step is to bring down that 2. And now I'm going to, I'll lay them out here, bring down the lead coefficient. Number 2, I'm going to multiply here. So I'm going to put in quotations, multiply. So 3 times 2 is 6. And my third step is going to be to add. So I'm going to add. Negative 3 plus 6 would give me 3. And I'm going to start with number 2 again. So now I'm going to multiply here to get 9. I'm going to add here to get 4. I'm going to multiply here, and I'm going to add here to get 0. Well, you'll notice I ran out of space right now. What does it mean? It means this is my remainder. What does it mean to have a remainder of 0? Well, that means 0 means it divides evenly. Let's write our answer. I'm going to show you exactly what that looks like. So it wants me to write it in fraction form. So here's fraction form. And you're going to see pretty quickly what that means. That means 2x cubed minus 3x squared minus 5x minus 12 over x minus 3 equals, well, what is my answer? Well, what is my answer? My answer is 2, 3, 4. But what are my x's? Is it x squared? Is it x cubed? Think about it for a second. If I take my lead coefficient and I look at my lead term, and this was x cubed, if I'm dividing it by a factor of x, what does my answer have to be in? It's got to be in 1 degree lower than I started out with. So if I divide by an x, which I did, I'm dividing it by x, it would be a 2x squared. So then they're going to step down from there. So this is going to be 3x and this is going to be 4. Well, notice, what does my answer tell me? Do I have a remainder? No. So what that means is that if I was going to put this in polynomial form, it doesn't say that, but I'm just showing you this. Polynomial form would look like this. 2x cubed minus 3x squared minus 5x minus 12 would be equal to, check it out. Polynomial form is what I divided by times my answer. So what did I divide by? I divided by x minus 3, so it's x minus 3 times my answer, which is 2x cubed, nope, squared. 2x squared plus 3x plus 4. What does that mean? There's no remainder. So that means that x minus 3 is a factor of 2x cubed minus 3x squared minus 5x minus 12. So that also means what? If I have something that's a factor of it, that means that 3 is a 0 of this because it divides evenly. When we factor a polynomial and we have that x minus 4 times x plus 2 times x minus 5, each of those tells me a factor, which means a 0. Well, in this case, because I have no remainder, that means that 3 is a 0. Okay, so that's why we're using synthetic division, and we're getting the preliminary skills reviewed so that way when we go to do this and we say, well, what does all this mean? Why are we using this? We're reviewing these skills so that we can say, okay, here's what I can find. I can find factors. I can find if there's a remainder, which can tell me, is there a 0? Is it a factor? How do I factor this using those things? Okay? Try this next one. So go ahead, pause, try it, and then turn the video back on, check your answer, review it, see what's going on. I'm gonna roll right into it, but if you want to pause here, you can. So this is my x minus k. I'm going to take my coefficients, 2, minus 5, 7, 3, 1. Sticking those underneath here. Outside, I'm putting my k, what's being subtracted, and I'm going to go right into my polynomial division using synthetic division. So I'm bringing down my 2. 3 times 2 would be 6. I'm adding those. I get 1. 3 times 1 would be 3. I'm adding these. I get 10. 3 times 10 would be 30. And this should actually be a minus 3 because I've got a minus 3 here. And so when I add these, I get 27. Oh boy, I'm getting uncomfortable. Is this right? Let's take a look. Okay, so I get 81. So here I've got 82. Well, if you're uncomfortable with that answer, you could go back and check. We're going to talk in a minute about what we could do to actually do it a different way and check. But let's just write out our answer in fraction form. Okie doke. Here we go. Fraction form. 2x to the fourth minus 5x cubed plus 7x squared minus 3x plus 1 over x minus 3 equals, here we go. Whew. All right, so I've got 2, 1, 10, 27, and 82. What does all this mean? What do these numbers mean? Well, remember, if I'm dividing by an x, that means my factor, or sorry, my power is going to be 1 less. So this is 2x cubed plus 1x squared plus 10x plus 27 plus 82, and this is my remainder. So it goes over my, what I'm dividing by. So my answer is, to clean it up, 2x cubed plus x squared plus 10x plus 27 plus 82 over x minus 3. So what could you do to check this? Well, you could do a couple of different things. Number one, you could write it in polynomial form. So check it out, polynomial form. We took the polynomial over here and we set it as a product of these two factors, and we could multiply it out and see if it actually equals. So we could write it in polynomial form. Check it. You could do regular polynomial division, okay, and see if it works. See, it would work the same way. We would just use regular polynomial division. That could work. You could graph this function and also graph this function to see if it works. I don't know. But what does this tell us? Well, remainder means x minus 3 is not a 0. Well, I should say 3 is not a 0 of this because there's a remainder. Okay? That's the basics of polynomial division and synthetic division. Thanks for watching. Please, if you have any questions, guys, let me know. Write them in the margin and we can talk about it in class. Thanks for watching, and we'll see you next time.